Hey everybody, welcome back. Today we're going to be working on the last question of the fall 2021 midterm exam. And this one's going to be really similar to question 8 in the sense that we're going to be modifying an architecture and we're going to be, in fact, adding the same instruction. But this time we're going to be doing it on a multi-cycle design, which tends to be a little bit trickier, but hopefully we can work our way through it. So this time, the only thing that's changed is now we can only modify 2 muxes, and we can still add 1 new mux. So what's going to change is that we reduced the number of muxes that we can change. As far as architecture goes, there's a few key changes. Obviously, we're going to be performing this in multiple cycles. You can also see that we have our unified memory as opposed to the single cycle representation where we were kind of splitting our data and our instruction memory. But yeah, let's go ahead and look at part A. So it says we need to implement this instruction in 4 cycles, and it gives us the first 2 cycle implementations. So those 2 cycles, if we think back to our state machine, there was like the initial cycle, like cycle 1, stage 1 and stage 2, and then we kind of had a splits by the instructions. So we don't really have the option to change these first 2 cycles, but we can decide the next 2 cycles for FC. So we need to first look at what's happening in those first 2 cycles. So in the first part, we're reading in our instruction, and then we are calculating PC plus 1, and this is just reading instruction. And then in the second cycle, we're setting PC is equal to PC plus 1, and then we're decoding the instruction. Well, the impacts of this, right? So if I wanted to set PC or register A to PC plus 1, what I can no longer do is kind of in the single cycle processor, I was using the output line of the PC plus 1 ALU calculation on that second auxiliary ALU to set register A. But now, because I don't have that auxiliary ALU, and I use the main ALU and just from the very first cycle start computing PC plus 1, what I can do is I can set register A equal to the PC. So the reason that works is I've already updated my PC to be PC plus 1. And so now my current PC is going to be the value that I want to be in register A. So how can I do this under the current architecture? Well, one thing we could do, and that comes to mind, is that without modifying the architecture at all, we could set register A equal to the PC by simply using, so in our current architecture, we have the PC here. And then if we selected this, we could get the PC here. If we selected 0 in this mux, right, the output here would be PC. And so then the ALU result would be PC as well. And then we could write that back on this line to data in, and we'd still need to add that extra line for reg A to specify it as a potential write back. But by simply calculating PC plus 0 and setting that ALU result to register A, we can perform that part of the operation. So we can perform the register A is equal to PC plus 1. So what we're going to need in order to do that is we're going to need to calculate the ALU result to be PC, or the value of the PC, plus 0. Remember, that PC is actually PC plus 1 because I already updated it in the first 2 cycles. Then in cycle 4, right, I can go ahead and assign register A to the ALU result. So that's what we need in order to perform this first operation, right? And we're going to need to expand this mux so we can specify that register A is a destination. Then for us to say that the PC is equal to mem at immediate, right, at an immediate value, what we need to be able to do is it takes one stage for us to load something into the data register. And then once we've loaded it into the data register, then we can write it. We can load it, right, into the PC. And so we might need to take, well, whatever comes out of this data register, right, and we're going to need to add it to the PC. And so the PC might now have a new mux, right, which determines which value goes into it. And so in order for us to do this, well, in cycle 3, we need to first get this value into the data register. And so we can do that as follows. And that's going to be mem. And then we need to be able to access our offset as an input there. So we might need to take like bits 15 through 0. We might need to take bits 15 through 0 that are right here and, have specify them as an input to the mux address, right? It'd just be another potential input. And so we need to select that for that mux. But we could use mux at that offset. Sorry about the color change there. Okay, so then once we've loaded it into the data register, we need to set the PC equal to the data register in the last step. And that should be the entirety of like the stage or the cycle breakdown for the function call opcode. So now we need to explain what muxes we're modifying. So I kind of went over this as we were moving through part A, but one mux that we're going to need to modify is that one that I have highlighted in pink, the mux address, right? Because I want my offset to be a potential input for that mux. So I would have mux ADDR having a the new wire coming from the offset, right, which is bits 15 through 0. Okay, so now that's that modified mux. The other mux that we talked about modifying was still mux our data, and we're just going to add register A as an input to that. And this is the same change that we made on the last architecture. It's mux dest, and then we're going to have register A, which is bits 21 through 19. I believe. I'm going to check that. Yeah, bits 21 through 19. So that's the two muxes that we modified. We also added this new mux over here for PC that would allow us to decide if we wanted to perform this assignment here, right? I'm going to change colors. If we wanted to perform that assignment, we needed to take our the output from our data register, and we needed to set it to the PC. And so one of our inputs is going to be our output's going to be the PC. One input is going to be the data register. And then the other input is just going to be whatever was the input currently. And I believe that's the ALU result currently. So awesome. So now we've decided on our muxes. The last part of our question is deciding what our cycles or what our control signals are going to be for each cycle. And so we're going to be referencing this part A a lot, as well as our understanding of these new modified muxes. So PC enable. So PC enable is just essentially in which stages would I ever want to modify my PC. So if I look at my breakdown from part A, in cycle 3, I'm never modifying the PC. I do read the PC here, but I never modify. But in cycle 4, I do modify it. And so it's going to be a 0 for cycle 3, but a 1 for cycle 4. The next is the mux address. So we expanded this mux, right? So it's now going to have, it said any control signals for additional outputs is going to be 1, 0. So do I actually, it just becomes a question of, is it going to be a 1, 0 or an X, right? Does it matter what the mux address is? Well, the mux address only matters if I am currently, if I'm performing a memory read, right? And so in cycle 3, I am performing a memory read, right here. And so my mux address is going to be set to 1, 0. But in cycle 4, I never access memory. And so I don't actually need to, it doesn't really matter what that mux address is. So we're going to set it equal to an X. So it's going to be a 1, 0 here, and it's going to be an X. And so this is for the same reasons, right? Our memory, and we only need to perform a memory read in this, and we don't need to perform a memory read in our fourth cycle. It doesn't matter whether we perform a read or a write for cycle 4 because we're not even performing it. It's disabled, right? So if this is a 0, these two are always going to be an X. But for cycle 3, are we reading or rewriting? It looks like we're reading. So this is going to be set to a 0 because I am reading. Awesome. So remember, for these, a read or write, it's always going to be a 0 or 1 correlating to a read or a write. Okay. So then we have our instruction register. So the instruction register just tells the architecture whether we want to read a new instruction at that particular cycle or not. So we should only really be loading a new instruction at the start of a new instruction. And so this should really only be happening, this should only be enabled in the very first step. And so in cycles 3 and 4, we should never be loading them. And so we should have it disabled. Next, we have our destination mux. And okay, for destination mux, shoot, I just realized something. This should be the destination mux. I apologize, guys. I had the inputs messed up. This should be reg. This reg A should be pointing here. I think I had it right for when I wrote it down. I said it was, yeah, the destination mux. But when I was drawing it, I just pointed at the wrong one. So this is the mux that we modified. And so if we're ever writing to register A, we want to set that equal to a 1, 0. And so which instructions in here write to register A? Well, that's just going to be this right here. In cycle 4, we write to register A, and so we're going to want to set it to 1, 0 there. However, in cycle 3, we're never going to be writing to our registers. We're never setting a register outside of the data register, right? And the data register is located separately. And so what we can say is if our data register is, or our register enable is 0 in cycle 3, then, and our register enable is 1 in cycle 4, then it doesn't really matter what my destination is or what's kind of been being written to it for the destination, right? So these are both going to be X's. So what value, the mux r data decides what value gets written to the register file. So the two potential values is the data register or the, it would be the ALU result. So in this last step, we are setting the ALU result equal to register A. And so the value that we'd want would be this line right here, which is going to be the lower one, which is a 1. And so my mux r data should be a 1 here. Next, we have our ALU muxes, right? So in cycle 3, do we use our ALU? Well, before we decide on these muxes, what I'm realizing is it's probably easier to, actually, no, never mind. In cycle 3, when we're calculating our ALU, right, we have two inputs. We have our PC and we have 0, right? So for the top mux, which is ALU 1, the value that we wanted was the PC, right? Because we were setting register A equal to PC plus 0, or in this case, the ALU result. And so we would probably want to choose 0 for that. The other value that was the input was a 0 for mux 2, because we wanted to choose PC plus 0. So the value that we're going to choose for that mux is going to be a 1, 0. In cycle 4, I'm not actually really using the output of my ALU, right? I'm using like the ALU result, but I'm never assigning ALU result to anything. So it doesn't really matter what the ALU computes at this time. And so we can set this both to an X. The same kind of goes for what operations occurring in the ALU. We don't really care what operations happening. And so we're going to set that to an X as well. In the very first, in cycle 3, we needed to add X to 0, or sorry, not X to 0. We needed to add PC to 0. So we wanted to perform an add, and remember, similar to read write, we have 0 or 1, and we have add or nor. So I'm going to perform an add operation. So this is going to be set to a 0. Lastly, we need to decide what the state of our new mux is going to be at each state. And so our new mux we inserted over here, and it's an input to the PC. So in the first cycle, well, we only care about what that mux is set to if PC is enabled. Because if we have PC and PC writing disabled, it doesn't really matter what I choose, right? So if we look at this, in cycles 2 and cycles 4, PC enabled is going to be true, right? Because we're setting PC to something. But in the other ones, PC in cycles 1 and 3, PC enable is going to be false. And so it doesn't really matter what this new mux chooses. So then in cycle 2, the value that we are setting PC to is the ALU result. And so the ALU result will be, well, it sort of depends. Sorry. Okay, so let's assume that the ALU result is 0 because it's like the older one. So if I redrew this, go delete some of this stuff. So if I redrew this, I would draw like, let's say we're gonna cut that chord. We're gonna have a new mux right here. And so this is gonna be the ALU res. And so that's gonna be at 0. And we're gonna insert the line from our offset, which I will do in black. So that line is going to come across here and it's going to input it at a 1. So our offset is going to mean a 1 and our ALU result is going to be inputted to a 0. So in cycle 2, we were assigning it to the ALU result, so it's going to be a 0. But in cycle 4, we were assigning PC to the data register. Oh shoot, I messed that up, didn't I? Yeah. Okay, sorry. This should have been a wire to this, not that. But we're going to want to choose our data register, which is a 1. And so our data or mux is going to be set to a 1. So I think we probably would have accepted those being switched because it doesn't really matter which one is high or low. But the important part is that they need to be different, right? Because in one, I'm accepting the ALU, and the other one, I'm accepting the data register. Awesome. So that is the entirety of this exam. We are done. Hopefully this was helpful. I'm going to try to put together a couple more of these moving forward, and hopefully if you guys think this was useful, I can do the same thing before the final exam for one of the practice exams. But if you find this helpful, let us know. I'm going to make a Piazza post with information about this, and so you can just respond to that. But yeah, thank you guys for watching, and good luck on your exams this week.